破门而开之间，谦虚半步，一人曾去目，孤行伫立待的日当正中，等教问句残花乎？第一口难辨是非，唯有墨鱼之术，盘中人皆得正业乎？而定问情伤风骨。生者一寸，一方便言和，一对对正主，有下人无语。红纸飞鸟唯有一人卡夫，对月相连，和手指相互，都是在无心日出。横听手指点那勾交接变化，笔走老舍墨书春秋尽潇洒，不见到秋千人并道尽舟上刻画，烟绝长万岁千载人生花，聊一书笔写遍古今的繁华，书经如变故自将历史传达，你总千年又有谁人能回答？一颗相信花香，对断烟点周沙。下出两天，大到一桌之间，饱食半边。愿我横双眼，坐立周家独根三指出言，地上边这般深渊。观沧海底水无存，只剩半杯四间，禁不住抗面无手住下飞开日出期限。闭目敬拜，为我而立一平衡我山前，长街尽目睹。若是日下竟有狮子沉淀，地下看烟，草人不见，定舍绿雾中头衔。水陆玄真举墨藏锋的章法，书斗南北交手相传半天涯。可问谁人流上之水，闻听众喧哗，欲知今朝报之下有几家，且把藏好书当年一起风发，看遍沧桑何惧岁月的冲刷，字字珠玑饶有几人能进化，正一书注一画，行万年笔下。我自作迷成字画，何问何答终感官，知晓吗？哇 ！Hello Simon, Hello Sky, Hello Cypher. Today we're gonna continue doing coding stuff. I also scheduled a Master Duel DC Cup later tonight. You guys can go. You guys can go. What do you call that? Wait, subscribe to the waiting room or something. Get notified on the scheduled stream. Okay, we study a new pattern. Introduction to sliding window pattern. In many problems dealing with array or linked list, we are asked to find or calculate something among all the subarrays or sublists of a given size. For example, take a look at this problem. given an array, find the average of each subarray of k contingent elements in it. Let's understand this problem with the example. Here we are asked to find the average of a subarray of 5 contingent elements in a given array. Let's solve this. For first 5 numbers, subtract from index 0 to 4. The average is so you combine the first element and then minus 5. The average of next 5 numbers subarray for index 1 to 5 is that for the next 5 numbers, the average is that. Here's the final output containing the average of subarray size 5. A brute force algorithm will calculate the sum of every 5 elements subarray of given array and divide the sum by 5 to find the average. This is what the algorithm looks like. Oh, so they basically put a for loop inside a for loop. So we think the inner for loop will basically loop 5 times and then calculate the sum and divide that. That's a brute force approach. Hello, Samuel. How's my day going? I woke up and then I did some jogging. I need to start not start, it's kinda already too late. But I try to jog a bit. I've been doing that for past week. So still a little late because I'm going to Italy and France next week. So I need some stamina. Right now my stamina is kinda garbage. I get tired from jogging 0.2 miles. Which is kinda shit. All things considered, it's kinda shit if I'm gonna be traveling and walking a lot. Can we find a better solution? Yes. The efficiency is any consecutive subarray of size 5. The overlapping part, which contains 4 elements, will be evaluated twice. Yeah. For example, the above mentioned inputs, as you can see, there are 4 overlapping elements between the subarrays, and the first one between the first one and the second one, these things are overlap. Can we somehow reuse the sum we have calculated for overlapping element? The efficient way to solve this problem would be visualize each subarray as a sliding window of 5 elements. This means that we will slide the window one by one element, then we move on to the next. To reuse the sum of the previous subarray, we will subtract the element going out of the window and add the element being included in the sliding window. This will save us from going through the whole subarray to find the sum, and as a result, the algorithm complexity will be reduced to big O of n. So that's what I was thinking before I start reading this as well. So you start traversing through this array, and until you hit 5 elements, you just basically add the sum together, and you save the first element in this window. So once you reach 5, then you can do the calculations, and then on the next move, you just slide window by 1. And now first you do is you minus the last element. Minus the last element and then plus the new element that's being added. And then you do the sum. Oh, so they now have a Windows sum and Windows star. Because this is given to them as an array. So whenever you keep pushing until you have the k number, and until the end is k minus 1, because in encoding array starts at index 0. So when you hit that number, you do the calculation, and then you shift the starting index by 1. You do that till you hit the end of the array. Yep. That's subarray. Next. Maximum sum of subarray of size k, giving an array of positive numbers and a positive number k. Find the maximum sum of any continuous subarray of size k. Maximum sum. Okay, so basically same as before. Instead this time instead of returning an array of average, we are returning the maximum sum. So okay, let's start. We start by defining a max to 0. And then we have subarray. We have sum. Subsum. I don't know. Starting at 0, and then we have Windows star. Is starting also at 0. So we traverse through the array, or let I equal to 0, I less than array dot length I plus plus, and then can you go up a little? Yeah. The question is, you find the sum of average number k within the array of continuous number within the array of key elements of continuous array, and then you just find the biggest sum. Okay, so for each element, we're gonna add it to the subsum. Subsum is equal to array at index I. So you can find the average of the array, then find the k index that's closest to the average. Oh, that's not how. This is a pretty simple thing. Join. which sort of duck won't join. Duck move online join. So you have like 1, 2, 3, 4, 5, 6, and then you have a number k. This is an array, right? The number is unknown, right? So they can give you any number k. Let's say k is equal to 3. You want to find the sum of continuous 3 elements within this array. Right, and then you find the next sum of next continuous element in this array. And then you find the sum of next continuous 3. Right, and then you just return the bigger sum. So what I'm doing right now is remember, like a brute force. A brute force is like you start the first index and then you calculate the next 3, calculate the sum and you go to the next. You find the next 3 and calculate the sum. But that brute force approach is the time complexity of this brute force approach is a big O of n squared. Because the k could be 6, right? That will render this to be big of n squared. So instead of doing that, we're gonna have something to memorize it. So we have we call it a subarray sum, subsum. Right? So we calculate this. And we have a new subsum. And then when we move on to the next one, right? So when we move on to the next one, we can just minus this one and then plus 4. So we do a -1 and then +4. That will be our new subsum. So we just keep a record how big. Like we just need to keep a record of the biggest number. That only works if that's not it. The array you don't care about array, sorry or not. Okay, the same approach. Let's say I have a 3, 1, 1, 4, 2, and then k is 3. It doesn't matter. You can still do sum of this. And then you do sum of this. You minus this, you plus this. And then this will be the new sum. And then next one you do the same thing. You don't care about whether this is sorted or not. If you have to sort this array, then the time complexity will become big O of n log n, which is not terrible. Because log n is actually, if you're gonna sort it, then you can actually just sort this thing into 1, 1, 2, 3, 4, and then you just take the last 3 elements. So now this is actually a pretty fast approach, but the time complexity is big of n log n, because the most efficient sorting algorithm is n of log n. Yeah. Okay, so we're gonna do the approach I mentioned. So I'm gonna have a subarray and we're gonna keep adding the array index 1. And then now if if I minus 1 is greater than, if I is greater than k, right now once we hit the number k, we know we hit the in the first iteration, once we hit the k, we know we have concluded one subarray. So once we concluded one subarray, what we do is subarray sum, right? If this is greater than it, and if the subarray sum is greater than maximum, then we just update maximum to be subarray sum, right? And then because remember we are sliding the window, we now need to remove the last element from this array. So what we can do is we have a window star to remember where the first element that entered the subarray, the index of the first element. So what we do is subarray subsum is equal to subsum minus array of the window star, right? And then we do a window star plus plus. And in the end, we'll just return the maximum. So if I run this, if I is greater than ke, I minus 1 greater than k. Next, still 14. I less than or than 5 plus plus. Subsum is equal to subsum minus array window star. Window star is here. Window star plus plus will be a 1. Okay, let's go through this. Subsum is equal to star. My subsum star is 0, so it'll be 2, and then because I minus 1, I right now is I said 0. 0 minus 1 is less than k. Well, I plus 1. I plus 1 greater than k. I is at 1 and k is at 3. And I is not greater than k, so this skips. And we go to the next. Next will be 1. So this subsum is at 3. I will be 1 plus 1 is still not greater than k. So we go to the next. Right, next is we go to next. Subsum is equal to 8 plus 5. Subsum is 8 plus 5. I mean 3 plus 5 is 8. And then now index is at 2, so 1 plus 2 is greater than. Oh, we should start the calculation right now, but I plus 1 greater than k. Greater than or equal to k. 1. Accepted. Submit. Accepted. So the whole thing was that remember we want to start doing the calculations when we hit that number. We hit the number k. I mean when the size of the subarray hits the number k, then we start the calculation part. And because I starts at index 0, so we need to do a plus 1. And what we had was if it's greater than, but we also want to start when we hit the k. So we do a if it's greater than or equal to k. This is hard. No. This is easy. This is actually easy. This is easy part. What is this site called? It's if you look at the top here, it's called Grokking the Coding Interview. You can actually follow along if you guys want to, but this is a paid course. Okay, next. Wait, I submit again. Damn. Next. Yeah, solution, blah 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 blah. So they did the same thing. Oh, in the end, they just do this. They do the max sum. We set the window sum for each window. Window sum. Wait, what the fuck? Wait, no. This is a brute force approach. That's a brute force. Don't look at that. So this one, right? So basically the same thing we did. Remember, the brute force was that for each index you're gonna loop k times, and then to get the sum, and then you go to next index and you loop k times, and this is the big O of n square. Let's see. Time complexity is the outer loop time complexity is O of n, and the inner loop is also O of k. If k is equal to n, then it's also inner is also n. So therefore, it's n times k, which is big O of n square, basically. So this is the brute force. So just to show you the time complexity of this one is not good. It's exponentially harder. It takes exponentially more time. And what we did is we have a k of 3, and then we look at the first 3 elements, right? And then we get the sum from we get the maximum sum from there, and then we go to the next index. So when we go to the next index, we're gonna remove the first index, and then we're gonna plus the next index. So instead of recalculating the 3 elements every single time, we just do a minus. We minus the first element, and then we plus the latest element, and then we calculate the sum, and then we do that until we reach the end of the array. So basically, this is exactly the same. We start with a window sum, window star, maximum sum, right? And then they traverse. Well, they kind of have a reverse, but it's the same idea. They look at the maximum sum, and then they're gonna minus the window star, and then they're gonna shift the window star to the next index. And this complexity is big O of n, and then space is big O of 1. This is big O of 1 because even though you are using you have 3 variables, you are storing stuff into 3 variables, right? So it's technically big O of 3, but remember, in big O notations we don't care about constant values. So big O of 3 is basically big O of 1. So that's why the space complexity is big O of 1. Okay, next. Smaller subarray with a greater sum. Given an array, positive integer and a number s, find the length of the smallest continuous subarray whose sum is greater than or equal to 5. Oh, equal to s. It's not 5. Return 0 if no such subarray exists. Okay, so 2, 1, 5, 2, 3. Output is 2. The smallest subarray with sum greater than or equal to 7. Smallest subarray. Find the length of the smallest continuous subarray whose sum is greater than or equal to. Okay, so we're looking for a subarray within this array, and we are looking for targets that's greater than or equal to the variable s, that the input x, right? And we're looking for the smallest continuous subarray that we can have, meaning that there will be least amount of elements within that subarray. So this is also similar to the one we had before. So what we're gonna do is same thing. We need to have a star, array star. Window star is at 0, and this time we need to keep track of the subarray size. Right? So we're gonna sub size. I'm gonna have a sub size is equal to 0, and then we also have a sub sum. Just use ChatGPT, okay. Good luck doing that on the interview. So we're gonna start traversing through the array. So let I equal to 0, and then I is less than array dot length, I plus plus, and then the sub sum initialized to 0. Sub sum is equal to sub sum sub sum is equal to array at the current index. And in this time we are looking for if the sub sum is greater than s. So if also we also need to keep track of the size. So each time we get a plus array, we're gonna subsize. We're gonna increase the size. So if the subsum is greater or equal to the s, the input x, we have found new subsize, right? Also smallest equal to 0. And once we found that, we're gonna do a subsize. We're gonna do a compare of the subsize. Smallest is gonna equal to math dot math dot minimum between subsize and then the smallest. So each time we found a sum that's greater than s, we have found a subarray that satisfies the condition to be greater than the input s. Of the sum is greater than or equal to input x. So each time we find that, we're gonna take the smallest subsize there, and then after that we just minus the subsize. We minus the subsize because we do subsize minus because we are essentially telling the the thing that telling the thing that we're gonna shrink this and then find the next smallest value. Isn't the first value? No, the first will not be always be the smallest. So 215, 152, 523, 232. Actually no. This is not sorted, so you cannot tell the first one is always the smallest. Again, you can speed through this if you sort this, but the time complexity, remember that time complexity is n log n. We want to try to reduce that time complexity to log n. So we're gonna do this in one go by memorizing the key values that we need. So after we find that, we minus the subsize, and then we're gonna take out. We know subsize, yeah, subsize, and then we're gonna take out. You're not good at time capacity. That's something you need to think about. Like, this is basically the efficiency of your algorithm. It's a measurement of the efficiency of your code. So how fast, how many loops, how many iterations your code will need to go through to complete this calculation is the time complexity. Okay, so we found one size, and what we need to do is subsum is gonna, since we're gonna take out the first element from this, so subsum is equal to subsum minus array Windows star, and then we do Windows star plus plus. I think this is frauded. If it's 7, right? This is 7. It's not. So I think this should be while, but we can go through this and then check that. So in the end, we just return the smallest. I submit. Output is 0. It cannot be 0. Oh, because smallest is 0. Because we initialized to be 0. So smallest will be math dot maximum value. No math. Integer. We just need a placeholder, so we're gonna do integer. Integer. How do you spell that thing? Num? Oh, number. Oh, number dot maximum value. And we run this again. So output is 3. Whereas if I switch this to while, run again, so it's 2, and then we submit this. Output is big. Well, subsum is greater than s. we're gonna do minus. So in this case, all the elements will not be greater than, combined will not be greater than that. So subsum is greater than s. How is it possible? Array dot length I minus. Hello. こんにちは。How do you get this big? So subsum is equal to 1. Subsize plus. Subsum is equal to 2. Subsize plus. Subsum is... So subsum is always less than s. So after this is finished... Oh, we just return the smallest value. Oh, we have the number as maximum. That's why it's just returning the maximum value. So if we don't find anything, let's see. If we don't find anything, find anything, then just num the maximum value. Smallest. If smallest is equal to num the maximum value, then we will return 0. Otherwise, we return smallest. Submit. Accepted. That's it. What language? JavaScript. I have a few options. No. Python, Java, C++, Go. Out of all these options, I think for me JavaScript is the most familiar. Out of all these, I mean, I know other languages, but I only have choice of 6 languages, and I just choose the one that I'm more familiar with. So yeah, and so that's the algorithm here. So same as before. We're gonna have a subsum that keep tracks of the sum of the subarray, and then we have the size of that subarray, because in this case we're only looking for the smaller size. And once the sum hits the target number, we're gonna start comparing the smallest value, and then we slide the window to the next value. And the reason why we use while is because you can have the latest element to be like very big number, and that very big number will you could get like 11111, and they have like 2 million, right? And that if the S is looking for 2 millions, if you don't have the while, it's always gonna be 1111 2 million, and the next one will be 1111 2 million 1, right? So the size will always be constant once you hit the first value. And because we have a while, so it will be 1111 2 million, and then we'll minus 11, and then 111 2 million, and then 111. I mean the 11 2 million 1 2 million, and then 2 million. So that will be that will shrink the smallest. That will eventually find the smallest small subarray, like smallest subarray that will reach the threshold. So that's why we do a while here. And then in the end, because this previously will return a big number, because I have smallest to initialize to be a very big number, because we are looking for very small number. So we do a compare. If this never triggers, the smallest will always be the very big number. So in the end, we just see if still If it is still the very big number, then we return 0. If not, then we return the smallest. Next. Alright, so window start, and then you go to the next one, window end, and you look at the required sum. If it's not hitting required sum, you start moving to the next window end. And then if it hits the required sum, let's shrink the window. You shrink by 1, and then you go to the next. You shrink the window until the window is smaller than the required sum, and then you go to next. And then window, just shrink the window, right? And then window is still greater than that. Let's shrink the window again. So this was 3 elements. So you shrink window, there's 2 elements, but this is still hitting the target sum. So you shrink it again. Shrink it again until you start next one. So you can moving the window end. This is how you find the smallest subarray to satisfy the condition. So what they're doing is they start with infinity, right? So they basically like this. The same as me. They check whether infinity, check whether this actually ran or not. If it doesn't run, and that means it's still at the initial value, infinity. So it just returns 1. That's what I did in the last one. And then they're looking for, oh, they're doing window end there. So window sum is equal to array I. This is I. While window sum is greater than, you do a math on min. Oh, in my case, I record the length, but you don't need to record the length. You just do the. This will be I minus window star plus 1. That will be the length. And then you do a window sum minus. The window sum, we're gonna remove the first element, and then you shift the first element. And this is also a while loop, so same as the one I had. Next, longer subarray with k distinct characters. Giving a string, find the length of the longest subarray in it with no more than k distinct characters. You can assume that k is less than or equal to the length of the given string. So string is ARAACI, k is 2. I'll put the longest subarray with no more than 2 distinct characters, ARRA. Okay, so it's giving a string and giving a number k, and you only can have 2 distinct characters, and you're looking for the biggest subarray by having only 2 distinct characters. Okay, so this is also building on top of this, but in this case, I think what we need is we need some sort of we need either a hash map or array to store the the characters that we have visited. So we know that the character we have distinct k number of characters, right? Okay, let's give that a try. You want to find maximum length of distinct characters. So we can do, let's still sliding window. So we're gonna do window star is equal to 0, and then sum is also equal to 0. And now we need a chart. We're gonna make a chart of a new. We're gonna make a new map for chart. 然后你们就 set. For let I equal to 0. And then pi is less than string. Actually, because I want to do array, so let's convert this string. String is equal to what was the fast way to convert string? JavaScript string to array. itu okay. So in this case, I don't even need to do that then. So I can do dot string. I forgot what this notation is called. String dot length. Actually, no, I still need to do a dot because I want to do the index. So string is equal to string to dot string. Right, so we do string dot length. Hello. How am I? Am I doing okay? We're solving problems. We are using brain. We are using the whatever brain cells that we have left to solve problems. And then I++. Well, actually, I can also do the start and end. Right, this will be the window end. Window n. Window n less than that. Window n plus. So what we're doing is that if the window star string and window star, if the first element of if the current element window star window n, if the current element is if char has this one, if char has the current element, all we want to do is char dot what am I doing? Char of the current element. Window n plus. And if it doesn't have that element, so we're gonna do char dot set. If it doesn't have the current element, then we do set window n, and then we set in the window n with the var 0. Wait, is this how the set works? String JS set? No, I'm not setting timeout. So we have map and set here. I set map. You said you adding this, adding this. I think I need map because we want the value. I mean, we want a key and a value basically. Right. So instead of set, we're doing map. So if chart has this, then we'll do plus plus. Chart.current plus plus. Otherwise, we set the current value. Right, so if we look at the map, where's map? Where is map? Map. Like map set this, map set this. Map.gets. Okay. I cannot do like array like stuff. So we want to increment the value in there. So we can do chart.sets. We're setting this window n, but we are setting the value chart.gets string at window n, and then we'll do a +1. Okay, so each time we traverse through the string, if we find an existing character, then we increment the existing character by 1. If we don't find an existing character, then we set the new key in the current map. And then while we're looking for key, while chart.size is greater than or equal to, what am I looking for again? Longer substring with no more than 2 distinct characters. So if you find the size exceeds the k, exceeds k, then we can do math. we want the biggest value. So we don't need sum here, we just need the biggest. So biggest value is equal to math the maximum biggest value and then char the size minus 1. The reason why we do minus 1 is we only looking for when it exceeds k. So when the exceeds k is when we add a new element, that new element goes out of bound. Right, so while it's out of bounds, we have found the biggest number. Oh, what we said this should be 1. Right, we found that biggest number. So what we need to do is if charts follow chart dot gets, we're gonna do chart dot gets. So now we are looking at the Windows start. Chart dot gets array at Windows, not array, string at Windows start. String at Windows start. If child dot gets string at Windows star is greater than 0. If this is greater than 0, that means we have items inside there. If it's greater than 0, then we have more than 1. Well, what I need to do is basically, okay, we have a substring. We want to take out the first element from this substring, and then we want to check whether this substring still satisfies the condition. So first thing we should do is take out the first element, right? Char dot set string at the Windows star is equal to it's gonna be equal to char dot gets string at Windows star minus 1. And then after we do the minus, if the char dot gets string at Windows star, if it's now equal to 0, that means we have taken out all the distinct characters. That means we have taken out all the distinct for that Windows start. If it's equal to 0, then we can do char dot delete strings and Windows start. And then at the end we just shift Windows start by 1. We're doing while because if you look at this case, the first element is first one that they found is here. So if we shift 1, that will be RAAC. That will still be the that will still be 3 distinct characters, right? So because we are in a while loop, this will continue until we have only 2 distinct values. Am I prepping for coding interview? I haven't applied for anything. I'm just I'm just doing this right now. I guess I'm doing it for fun, which is weird, but eventually it'll be useful. Run this. Output is 0, which does not make sense. So window n is A. If actually, you know what? I can just do this test case. Console char low values, and then run this. Oh, it returns are iterable. Console log. Console log map. Theme.js map. Map object entries. Okay. Entries. Powerful entries. Entries. Run. This thing already. Chart entries. Chart is not iterable. Oh, this is a function. Chart entries. Run. So right now we have A at 1, R at 1, A at 2, R at 1, A at 3, R at 1. Oh, it never exceeds K. If chart.size is equal to K, then we calculate the biggest. Then run this again. Shoot 2. Well, actually, I know why. Size. So if I do a console log r.size 1, so 1, 2, 2, 2, 3. And what was the K? What was the K value? K value is 2. Biggest is called the biggest. Total size. So while chart.size is greater than K, greater than or equal to K, it should be greater than K. Right, so when it hits here, chart.size is 3. It should be, so chart.size is 3 is equal to greater than K. And we know K is 2. So this should run. Math.maximum biggest chart.size. Oh! I'm not returning biggest. God damn it. I was returning the default value. Oh, because they have a length here. Okay. So run this. Output is 2. Expected is 4. Okay, at least we progress in somewhere. Oh, chart.size. Oh, I see. Biggest chart.size. Because the size is 3 right now. Char is 3, but we want to count A 3 times, right? This is where the problem is. And if I iterate through that, that's gonna increase the time count. Technically, yeah, that's gonna increase the time complexity. So instead of doing size, we do need a subsum. So every time when we add a new, every time when we iterate this, we're gonna increase the subsum by 1. And then, so every time we remove something, so subsum. Every time we iterate through this, we're gonna remove a subsum. Minus. Then run this again. No. Output is no. Okay, subsum is not a number. Initialize to 0. Output is 5. Every time we increase this, oh, subsum -1. Run. Accept it. Okay, submit. Output is 0. Expected is 5. Oh, this is where they're coming. This is we only calculate this when it exceeds the size. But we don't need to do that. So if char.size is equal to k, then we calculate the biggest. We run this again. That's 3. We don't need to -1 anymore. Run this, submit this, accept it, yeah. Oh, that's it. Submit. Next. So what we did was that you have a window start, you have window end. We're gonna have a. Are they using a? Yeah, they're using hash map. So same thing as what we did. We're using hash map. So we are pushing the Windows starts into the hash map, and then increase the length by 1. And then next we pushing the next character into the hash map and increase the length by 1. And the next we push it again, increase. We push again, increase. And then next one we found a numbers. We found a number that will exceed the distinct value. I mean, we found a character that will exceed the distinct value. So what we do is we're gonna start shrinking. We're gonna shrinking the start. We shrink that by 1, and then we look at that. We look at the number of distinct value again, because we have a hash map, right? So we're using hash map to store each distinct character. So the size of map would the size of the hash map would describe the number of distinct characters in our current subarray. So you just simply do a hash map.size. In this case, it still exceeds the number k. So we start shrinking again, and we look at this value again. Now it's less than that. Now it's equal to k. So now it's equal to k, but we already calculated the maximum value. So we're gonna start to go to the next one. We go to the next one and then look at the value. So go to the next one, and then we start shrinking it again. What are you coding for? Just for fun, right? I guess right now it's just for fun. I haven't applied for any job. Ever since I got laid off last year, I haven't applied for anything. I tried doing like all the VTuber stuff, but it makes no money. VTuber makes no money. I'm basically in the minus right now. So we traverse through this until it's then we just return the maximum left. So what they did was that, okay, they have a hash map. Lore dropped. Okay. My lore is pretty boring, I guess. But I was like, okay, so for those that don't do coding for a job, the stuff I'm doing is the stuff that big companies will interview you for, but this is not the things that you actually do your job. So in my past job, I have never ever done things like this, like sliding window or pointers, fast slow moving pointers in an actual job. We code stuff. We're not solving algorithm that's already been solved. So this is why, like, even for like experienced programmers, that like even they have done very even that's very skillful, they have made like big applications or big open source projects. Sometimes if you just throw them into this kind of interview, they will still struggle. You rather do take home assignment. The problem with take home assignment is that people can cheat. The ideal situation is like that's why they actually test you both. They will test you this, and if you qualify, they will go into the next, and then supposedly give you a real world question for you to solve. Okay, so in that case, they just do a hash map, and we just do a map. So when we were doing a lot of, like, I guess, somewhat unnecessary setting and then deleting stuff. They did not convert. They did not convert. They did not convert the strings into array. So they're doing this. So the first character is the current character in there, and then if the current character is not in the hash map, they're gonna create a hash map. Otherwise, they go. Oh, actually, this is smart. If it's not in the hash map, you create a hash map and then you increment by 1. Yeah. Basically the same thing, but it's shorter. Right? char.set well, I guess the same. 0 and then char.set. If it doesn't have that, then you just set it 0. So same thing. If I run this, it's still the same. If it doesn't exist in hash map, then you create that and then you just increment it. And while the key kind of reverse order, but still the same. While the hash map has more keys than the input key, they're gonna remove the star. They're gonna attempt to remove the star. So you look at the hash map of that character and then you do a -1. And if the hash map of that character is already at 0 at this point, then you delete that value from the hash map and then you slide your window by 1 until the element is equal to k. Right, and then you calculate the maximum length. Yep. That's it, done. Next. Should I continue? Next one is medium, and then we're going to the hard territory. I guess I'm gonna stop it here. I will see you guys later in the master duo stream. And thank you for watching. Bye bye. 心当初有多么激励，如今摸着胸口就都冷冰冰。数一数身上寄出淤青，还剩多少不是个说，证明我也曾经叛逆过，我也曾经离家出走。